Chakravarti. My topic of teaching is chemical bonding. So let's start. Chemical bonding. What is chemical bonding? Bonding of two atoms to form a molecule or a group. Like molecule is carbon dioxide or group is CH3 group. These kind of groups. Or molecule is chlorine. Now, how these molecules form? Via bonding of carbon and oxygen. Here C, H, H, H and one radical. And here Cl, here it is Cl and Cl. So what is this? This is bonding. And what is this bonding? Bonding is mainly of two types. One is intramolecular, that means two atoms coming together to form one molecule, and supramolecular or intermolecular. This is bonding between two molecules to get more attracted. That is ion, and these mainly forms by the interactions. Ion-ion interaction, energetically more favored than ion dipole, energetically more favored than dipole, energetically more favored than dipole, induced dipole, and van der Waals. This hydrogen bonding is a separate thing. Hydrogen bonding could be as good as ion dipole interaction or as good as dipole, induced dipole interaction, both. And this makes the hydrogen bonding most attractive one. And as we know, DNA that is in our body, that is also formed by this hydrogen bonding. Okay. Now let's come to intermolecular bonding. Intermolecular bonding are mainly of three types: ionic bonding, covalent bonding, and metallic bonding. What is ionic bonding? Here one metal, preferably one metal and one non-metal, comes together to form a more stable atom. And stability is the key of formation of any bond. This sodium molecule has electronic configuration of 1s2, 2s2, 2p6, 3s1. If it loses one electron, it becomes 1s2, 2s2, 2p6, which is the electronic configuration of argon, stable noble gas argon. And let's have a look at chlorine. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6. 3p5. If we add an electron, it becomes 1s2, 2s2, 2p6, 3s2, 3p6. That is the electronic configuration of another stable noble gas, neon. So what happens? This 3s1 electron is donated to 3p5. 3s1 electron of sodium is donated to 3p5 electron of chlorine. So they form Na plus and Cl minus, and the opposite charge of these species bring them closer and attaches them. Energetically, it is more favored than, it is stronger than covalent bond. Now, what is covalent bond? Covalent bond forms via equal sharing of electrons between two atoms, preferably non-metal. But there is another type that is called coordination bond. That also comes in covalent bond. We are not discussing that here. So covalent bond, they preferably forms between two non-metals. Like it is formed here in CH4. Here this CH4 formation is shown that carbon p orbital of carbon is attached to s orbital of hydrogen to get a CH4 molecule, and the electrons are shared equally. Now another bonding is metallic bond, that is mainly observed in metal clusters. Here two types of metals, and they can bind together, and electron, since all metals have plenty of electrons actually roam freely from one to another, like shown here, CuFe. And cluster structure is not drawn here because the drawing that is not possible in the board. Now let's come to three parts of covalent bonding. Since we are interested in organic chemistry, we will go to covalent bond. So covalent bond is like single bond, double bond, and triple bond. What is single bond? Like shown here, let's just concentrate on these CC bonds. One sigma bond has bound one CH3 to another CH3. This is called single bond. Now, what is double bond? Double bond is one sigma and one pi bonding. That is shown in ethylene molecule in these two carbons. And what is triple bond? That forms between two carbons in one sigma and two pi. Now what is sigma? Sigma is axial overlap of S and P. Here S and P, otherwise it could be P and P also, like happens here in CH3. So axial overlap of two atoms. Now what is pi bond? Pi bond is sidewise overlap of two bonds as shown here. These two positively charged positive lobes bind together or interact together to form a pi bond. Energetically, triple bond is more stable than double bond, and double bond is more stable than single bond. Bond length also increases. Bond length of triple bond, this bond length increases in single to double to triple. Since more binding is here, more electrons gather in this binding, the bond length decreases. And in double bond also, since it is less than triple bond and more than single bond, so double bond has moderate bond length. But single bond, it is only formed by one sigma bond, and therefore the bond length of single bond is the highest among the three. Okay, thank you. That's all for today.